Thank you, guys. So my name's Gary Hallam. I run our sales engineering team across Europe. I've got one guy in the Ukraine who covers the whole of Russia and Eastern Europe. Very small company. Before that, I was working for Oracle. I first started testing in 1987. So who was born after 1987? Someone must have been, yeah. So I was testing before you guys were born. That's scary. I had a very easy paper round, and that's why I look so young. And I've only got 5 children, would you believe? Okay, so this is my second time in Moscow. The last time I was in Moscow, I came by train from Beijing. It was a hell of a long journey. It was much quicker this time. But I had a bit of an accident on the way here. And always, I think when you're testing, you want to limit the possibilities for error, right? Because things always go wrong with testing. So the thing that went wrong for me yesterday was I left my laptop in the security tray. So I arrived here with no presentation, so you're lucky to have this today. Thank God for the internet, that's what I say in the cloud. So here we are. Okay, so I'm Gary Hallam. I'm going to talk to you about improving test data for shift-left automation. Does anyone know what that means? Shift-left, I'm assuming it's tested. No, you don't know what it means. So what that means, in the first presentation I saw today, I think, Steve, there was a question at the end, and it was about user acceptance testing, and the problem was at the end of all of the testing, we get to user acceptance testing, and at that point, the users arrive and they say, this is not what we wanted. And so they want to design the system again. So shift left is all about doing the testing earlier and getting all the problems out of the way at the beginning, so then you can actually get a better solution, more better quality to the solution. So last year I was at a test conference and I was running a round table. I did 3 sessions of round tables, and we asked the question, what are the biggest problems in test data management? And these were the top things that came up. This was only a survey of about 50 people that came to the conference. And one of the main problems was lack of automation. We talked about that today. Need for bugs to shift left. And that means find the bugs when the developer develops the code rather than when we get to user acceptance testing. There's an issue with security and masking. We want to use production data, but there are a lot of regulations that are coming into force these days and means we can't use production data unless it's masked or pseudonymized. There's a new word that came out in the UK recently. Problems with provisioning time. How long does it take to provision an environment? 12 people want to test and there's not an environment where it breaks, and we need to get that environment available. High costs, and that's high costs for developers, high costs for systems, high costs for software. Insufficient test plans was a big one. So, test that. How do we want to test it? Just test it. Just get it done. We just want it fixed. We want it working. How should it work? We don't know. Lack of devices for testing. So back in 2000, I was testing. I used to run a service for Orange. Orange was a mobile telephone provider, and we created MMS messages. I don't know whether you know what they were, multimedia messages. And this was in the days before Android, before the iPhone. So this was in the days before, I can shout, it's okay. That new battery was obviously an old battery, right? So this was in the days before the iPhone, before Android, and so I had a desk bigger than this, full of all sorts of different phones. And so from now on, I hate mobile phones. I hate touching them and finding out how they work. And because they all had different message sizes, it was a nightmare. But that was some of my testing experience. So, what are the goals for test data management? If you look at getting data, so the best data we can get is obviously full production. If we get full production, that's fantastic. We get good quality data. But the problem with getting good quality data is the speed of access to that data. Obviously, in some testing cases, we do data subsets. And usually data subsets are great for unit testing. But when it comes to a big complex system, it's very, very hard to subset data. I was working on an EBS system. I used to work for Oracle, and one of the guys at the conference there once said, have you managed to get subsetting working for e-business suite yet? And the answer was no. And then there's also synthetic data. So synthetic, you want to create the data, and that's really, really useful. I was talking to a bank, Lloyds Bank in the UK, and they said the problem with synthetic data is that our systems are so old that we can't cover all the test cases. And bank accounts like my bank account, which was started in the 1980s, they break the system, and we can't synthesize that data. And then obviously you get to the point where, sorry, I always wanted to be a singer. So then the other idea, we get shared data environments, and shared data environments are great unless someone else is using that environment and they take all of your data. I was talking with an online retail company in the UK, and they had two problems really. They had one of the problems was who took all my inventory, so who took all of my data, and the other one was that the problems they found were not found in test because the data was old and not refreshed. So the answer, that I think the answer is virtualizing the data, so getting virtual data. So what does that mean? And I think if you can virtualize the data, it means you can get full production copies very, very quickly, but then you can also do all of these other things on that virtualized data. So what is virtual data? Okay. So, and why do you want virtual data? So one of the things I came up with the other day, I was in Africa a few weeks ago, and it was nice there. I actually used to live in Africa. But I think moving data is like moving elephants. So last year, the royal family, so a guy called Prince Harry, anyone know Prince Harry? He was in Africa and they were trying to move 500 elephants from one reserve, 200 miles to a game reserve, in order to protect the data, this endangered species, which is real data, or real elephants. And the reason moving data is like moving elephants is it takes a lot of effort, right? So if you're wondering, that ginger-haired guy there is not me, that's Prince Harry, okay? Out of the 500 elephants, he only managed to move 231 of them, so there's still 279 elephants to move, and he's like, he's going to do the rest of the job this year. So it takes a long while to move data around, and it's hard, and it takes a lot of hardware. Okay, so you need a lot of hardware to have data around. So virtual data gets rid of all of that. So what is the other problem of the fact that you've got a lot of effort, a lot of hardware, is the fact that infrastructure is expensive as well, and that's difficult to get hold of. So even though you might have a DBA out there that can give you spin up a database in hours, because if you've got 10 terabytes of data, that's going to take a couple of hours or a few hours or maybe overnight or over the weekend to produce. That's going to take time. But even before you get to the DBA, you've got to get the manager to find somewhere to put it. The sysadmin's got to find a server for you, spin that up. DBA's got to find some backup that he can restore from. The storage admin's got to give you some storage, and the backup admin's got to get involved as well. So there's a lot of people, and each one of those guys has an SLA, and that's great. But if you're outsourcing that work, you're outsourcing the infrastructure, it gets even harder, because then it costs money and it just gets horribly slow. And I'm going to tell you a story. Well, before I tell you a story, so that's the situation, right? Please can I have a copy of the production data, because this guy is waiting to do some work, and the boss, the storage admin, DBA, go, no, too busy, can't do it, too much time. So I'm going to tell you a little bit of a story. So I went in to work for a company called TUI, the travel agency. I shouldn't have said that, actually. Scratch that out of the video. So this company, we were trying to show how our product worked. In order to get the product to work, we've got to put the product in place. Their existing infrastructure was stressed. They had 5 test environments. They had no infrastructure to put that on. So what we tried to do was to find some space, and we almost got there, but we needed a lot of storage. And they couldn't get the storage, so we were going to have to get some approvals to get some storage, to spend some money to start the project. This took 6 months. 6 months. So that's the difficulty that you've got. So when we got the approval, we provisioned an environment. They'd used the wrong operating system, so we had to start again. When they wanted to start again, there was a production problem. When they had the production problem, there was a 2-week delay. That project delay of 2 weeks took us into the Easter holiday. This was last year. And we weren't going to be able to do it. We're going to have to just delay it even longer. Instead of delaying it longer, we proceeded with limited staff. And obviously when you proceed with limited staff, then you get some issues. We had some production issues. And in fact, the production issues, one day after we got on site, the next day at 5 minutes to 9, I got a call saying, don't send anyone. I said, the guy's already at the door, he's coming in, we're going to do some work anyway. Then they said, oh, you're trying to connect to our production environment. You're not allowed to do that. So the security people got involved, we couldn't connect to production. We got over that issue. Then their prerequisites didn't meet our requirements. And then, because we were 2 weeks delayed, someone else was using our environment. They were doing some month-end testing. Of course, we blundered in there, we got this environment, we put a new database on there. Their month-end testing crashed. and we were requested quite strongly, that means we were sworn at, please leave our system alone. And there was an F word in there, I don't know how that translates, but we had to stop using that. So then we had to provision another environment, we got another piece of infrastructure. That was a single instance, we had to fix that up. It was the wrong version of Oracle, but we used our virtualization because we can virtualize file systems, so we created a virtualized Oracle home. They said their masking job took 24 hours. It was very primitive, it wasn't protecting data at all. And a lot of their personnel that they wanted were all away or testing other things or on holiday. And that was problems. Now, I imagine this resonates with you, and a lot of that happened to you. So when we actually implemented this system, we got a virtualized environment in place, we improved the results. So I'm kind of sort of selling here, but we actually got the refresh cycle down from 9 days to 10 minutes. They had a masking SLA of 24 hours. They were only masking 6 columns. It took us half a minute to do the masking. We could self-service, so now we could self-service their DBA, the refreshers and rewinds, we'll go into that. We can actually replicate into the cloud as well, because we're not moving all of the data, we're moving virtual data. And we give them 90% storage savings. And in actual fact, a couple of weeks ago, in another presentation we were giving, was one of my colleagues, they said they were saving $200,000 a month on storage. We sold the software too cheap. It was about that sort of money. Anyway, so let's get back to these elephants, right? It's hard to move elephants. So if you've got a production environment, typically when you're going to do non-production, you may test, dev, pre-production, QA, whatever. If you've got 10 terabytes of data here, your elephant, then you're going to have to move that elephant around quite a lot, and that takes a lot of effort and a lot of infrastructure. So what you want to use is virtualization. Now, there are many types of virtualization out there. So Oracle has its snap clones. I don't know whether anyone use Oracle databases? No Oracle databases? At least 5 or 6 or 10 of you. So Oracle has a thing called Enterprise Manager. It has snap clones. It does thin cloning of data. It's a storage capability that is provisioning the data for you, but not all of the data. And I'll come into how our product works in a minute. And there are some storage tools out there that also are able to do a thin clone of your data. So the product that we have is a thing called Delphix. So what we do, instead of moving the data around, we move the data only once. So you've got your database here. We move the data once, so we ingest the data using the backup technologies that people are used to, so SQL Server backup, native backups. In Oracle, we use a thing called RMAN, Recovery Manager. That pushes the data once into what we have here is a copy-on-write storage device. Does anyone know what copy-on-write means? Okay, it means that we don't delete anything. Any change that we make, we create a new block of data. So, question for you, right? If I delete a file on this PC, what happens to the file?
Nothing.
Anyone?
Nothing.
Nothing. No, that's right, the right answer. So if I delete a file on this laptop, nothing happens to that file. All that I do, I tell the operating system, you can overwrite that file now. You just remove the pointers to that file. And then the operating system, when I'm writing to this operating system, that file may get written over. Okay? In the technology that we use here, what we're actually doing is working on pointers. So when I've ingested data, I do incremental backups forever. So I bring the data in once, I compress that data down to about a third of its size, and then I do an incremental backup forever. So I add data to that, so I do a copy on write. And now what I have here is a rolling live archive of data. I have, rather than having a backup, I've just got a block of data from which I can provision a virtual copy of the data at any point in time of that data. And I provision that data, virtual database, onto any one of these targets. When I provision it, I don't actually move any of the data around. So I have 10 terabytes here, it turns into 3.5 terabytes here. When I provision a virtual copy, all I do is create a mount point here. If anyone knows NFS, we use an NFS mount point, or if it's SQL Server or another database, we use iSCSI. But it means I create a mount point, And that mount point, I create a pointer into the data. So I'm only pointing to the data. So that data is compressed here, and now I create a pointer to the data. And that pointer, the size of that pointer is a few hundred megabytes. So 10 terabytes, call it a couple of gigabytes of data. So it's virtually nothing. So I've got a full database for nothing. And it takes me, for 10 terabytes of data, I can deliver that in about 5 minutes. So Ingostrach, has anyone ever heard of Ingostrach? So they use the technology that we've got. They've got a 20, 30 terabyte database. It's 20, 21 terabytes. That gets delivered in about 9 minutes. Okay. So all we're doing is putting the data, we're creating pointers to that data. Now it's a full database. It looks, smells, feels, and tastes like a database. You can back it up, you can do whatever you want with the database. And it gets there with zero footprint in minutes. If you change a copy of the data, if you write to that database, you get another pointer to your personal piece of the database. Okay, so you're effectively sharing the data. So I can create another virtual copy and another virtual copy, 3, 10 virtual copies of data. All I'm doing is sharing the data. But when I write to it, I create my own pointer. And the file system here, the Delphix operating system here, manages those pointers. Okay, so that's great. So at this point in time, I can give production data in minutes, and I can write to that data, and the value of the technology we've got here as well, we copy on write, because we're managing those pointers, we can actually go backwards and forwards in time. So the final piece that we've got that really is the icing on the cake is self-service. So not only can we deliver databases, and the DBA can do that for you, but we can actually give you a container with those databases where you can run some self-service. And within that self-service, you now have some capability to start the database, stop the database, in a kind of a Netflix-like user interface. So we've got a web browser which says start, stop, bookmark, branch, rewind, and reset the database, and refresh the database from production as well. Now, if you want to know how that works, and you'll get a copy of these slides, Google Jonathan Lewis explains Delphix at Oracle OpenWorld. And that describes the type of copy-on-write storage, and he does it in a much more eloquent way than me, and it just describes how the technology works. So anyone wants to understand the technology, have a look at that. The Oracle ZFS file system is a copy-on-write technology, and the guys that started the company that I work for actually built that file system. So that's what it looks like. So we have this Delphix engine, which is a virtual machine. You just import it into a hypervisor, VMware. We've got an Amazon machine image. We're on the Amazon marketplace as well. We can run an OpenStack on a VM, and we're bringing out an Azure version as well. Beauty is that it runs a number of databases. Because we virtualize any file system, then it means we can virtualize any database. We can virtualize any application as well. And we run on any storage. Obviously, because we've compressed the data, in the engine we've got a lot of RAM, so we do a lot of caching, so we cache the data in a compressed way, so we've got 3 times as much data in here. We require quite a high bandwidth to the target from the Delphix engine, and we run just about on any storage, but we prefer solid state. We prefer flash. Because if you can imagine, I've compressed one database and I've got 10, 20, 30, 40 copies of it all sharing the same data, then I need quite a high throughput there, and I need some quite fast storage as well. But because you're running a high cache here, it means a lot of the I/O is offloaded to the engine that we create here, which is running on the hypervisor. So that's good. So we now got a copy of this data. On the operation side, there are a number of things that we might want to do with that data. So one of them is masking the data. So obviously we copy production. Every time we copy production, for non-production purposes, we want to secure that data. And especially with the new regulations coming in, GDPR, and I think Turkey brought in a new data protection regulation in April last year. It was supposed to be implemented in October, but there have been a few issues in Turkey. I don't know whether you noticed. So they're not enforcing that regulation at the moment, but they said they were going to enforce it in October, but I'm sure it will come in soon, once everyone gets their jobs back. So we can do stuff with transforming, so we can do U2L, Unix to Linux transformation. Automation. So I don't know if anyone went to the REST API discussion. So all of this for us is built on a REST API. So anything you can do in these two user interfaces, you can do in REST as well. So you can automate that and put it into your continuous integration or your DevOps lifecycle. So the value really for data is the fact that if you can spin up an environment, one of the issues is getting the data, the full production data into that environment. And we can now do that. So you can put data into your Docker container in minutes. And then the self-service interface, as I said, you can refresh, bookmark, branch, rollback, and synchronize the environment. I'll show you the value of that now. So the user interface for self-service is a bit like Netflix. So you've got some big buttons at the bottom, easy to use. Switch between branches, bookmark, create a branch, share your bookmark, rewind, refresh, reset, and stop. Easy. So you don't need a DBA anymore, which is fantastic. So you're on your own, you're responsible, which is kind of good. When I was in Africa the other day, I told this to the developers, and they thought it was a great idea. They went away, and overnight they came back and said, "Oh no, it's not very good," because now it means they're not going to use the excuse that they're waiting for the data, so they were going to have to work sort of every day, which is a shame. Okay, so this is the timeline of the data. So you can pick a point on the timeline and say, I want to bookmark there, I want to refresh the data, I want the data to that point. So what does that mean? If you look at self-service, so what we're able to do is we give you a template. So these are the source database, and I can have multiple sources, multiple virtualized sources, and then I can then create a container. So I can take a clone of all of those, and I say, here's my virtual databases and virtual files. Here's one, and here's another one, and I can give those containers to developers. I might give it to a test manager, and he manages that environment, or I could actually give virtual databases to every developer if I wanted to. So that makes up an application that I can branch, bookmark, refresh, rollback, mask, integrate, and rewind. So now, that's the user interface that you can see. Here's my system, my virtual databases, and what that means is I can run some tests. I can then bookmark the test. So bookmark, what that does, when I talked about the pointers, it takes all of those pointers and says, right, let's do a snapshot of the pointers. So now I've got a snapshot of those pointers, I can do some more work. I get to another point, and now when I've run those tests and I've broken everything, I always break everything, then I can rewind. And I rewind, but I know when I'm rewinding one of the databases, I'm rewinding all of the databases back to a point in time. And this, as a user, tester, you can do. So there was an integrated reset, so I can reset to a point in time, the last point in time that I used. But I can also do a refresh. And what a refresh will do, we'll get the data again from production. Now that's going to overwrite your data. But if I've got a bookmark back here, I can always go back to my bookmark. And I can roll forward to a bookmark and back to a bookmark. So that's a refresh. So what's the value of this, right? So one of the things that we can do is if a developer's ready to start on another release, he can create a new branch before starting. So the idea of a branch is I've got my virtual database, that's mine, I can do what I want with it. One of the things that I can do is create a branch. So now I'm copying those pointers, I'm restarting the database with a new set of pointers, and then at that set of pointers I can refresh, or I can subset. Or I can put some stuff on that database. I can delete all the files and create a whole new set of tables in that database. I can do some work on that, and then I can go back to the other branch. So if you're testing one environment, but someone says, oh, this is more important, or I've got a production problem, you can go down to another environment. You're on the same target. All the connections to that target are the same. That means you haven't changed anything from the application, but you're on a completely different database. And what branching gives you actually is versioning of your data. Okay, so now you can version the data, and I can create as many branches as I want. And each branch is going to create a few megabytes of data, but you're still sharing all the storage at a different point in time. So you're not creating that much more storage. So you've got 10 terabytes of storage that you're using multiple times on virtually no storage at all. It's magic. Virtual data is magic. So you can undo and test. So if you've got a developer, you're sharing an environment, one developer comes in, breaks everything. The test developers can't work, but that developer can reset the database, and then make changes again and test at another point in time. Right, I've got 15 minutes left. That's 15 minutes to beer time. So I'll try and speed up. Let's see if we can get out of here in 14 minutes. So we can increase the quality and speed up the delivery with self-service. So I talked about branching. We talked about resetting. You can activate different branches. So I think you get the picture, right? So one of the other elephant theme here, slong. Was it slong? Did I get it right? Slong. Elephants. Okay. So the other elephant in the room is this, security databases. But actually, security is really a problem. In production, we all protect our production data. And I was talking to a Swiss bank the other day, and one of the things that we have to do as Delphix is connect to an SSH connection into the production database in order to fire off the backup, or in SQL Server's case, to go and find where the backups are. And he said in Switzerland, no SSH inbound to our production environment. No way, not no how, not ever. That's a little bit of a problem, so that we're putting a fix into the code to try and mitigate that. Anyway, so production data is protected, non-production data, which is where most of your data is. I was talking to a German auto manufacturer the other day, and they said they had 60 non-production copies of their SAP environment. And their non-production was massive compared to their production, so the cost of non-production was huge. They still haven't bought the software yet. So the problem is the elephant in the room. And also the GDPR regulation. This is the European regulation where we're going to penalise you 4% of your global turnover. It's quite expensive. The result of this new regulation actually in the UK has resulted in many companies hiring many more lawyers. They're not fixing the problem, they're just going to offload the problem. So inside of Delphix, or in any virtualization solution, you need to use security. So Oracle has this with its snap client capability. We have a solution which we call masking on the virtual data. So this is quite useful. I mean, the capability you want to mask once and share. So the biggest problem with masking your data is not actually doing the masking, which is a big enough problem as it is, but it's actually once you've masked the data, is getting that data to people that need it. So with virtualization technology, you want to be able to clone a clone. So if you create a masked virtual copy of your data, so now you've got minimal storage, you're masking that storage. What you can do with virtualization is copy that masked data many times very, very quickly. So you get your 10 terabytes out there in minutes. Masking needs to be simple and easy to implement, easy to use. A lot of the tools that are out there today that either you've got homegrown scripts or stored procedures or ETL kind of tools are quite difficult to use. So you kind of need to understand stored procedures, or you need to understand code in order to make the masking work. And often they're they're different for each database. So with masking, you want to be database agnostic, and you want to be automated. You want to have kind of an enterprise architecture and by that I mean you've got to have a kind of a master-slave capability, because your enterprise is huge. You want to mask all of your data in the same way. So Gary Hallam needs to be masked to John Smith in every single application that you've got and every data file you've got in the enterprise. In order to do that, you need to be able to do the same masking process on all of your data. So you need the master algorithms, and you need to run those where the data is. And the other thing about enterprise architecture is I'm sure you all change your password on a weekly or bi-weekly basis. But obviously if you're going to mask something in a production environment and you keep that same, because we use some keys for doing some of the masking, then you want to be able to change that on a regular basis as well. It's still quite a big job and not many people do it, but the capability to do it needs to get out. So with Delphix, we can mask very, very quickly. We can mask on multiple databases. You want to be realistic, so the masking has to be realistic. So one of the algorithms we've got is a secure lookup. So we create a table. So if you're looking up first names, you take what we do is hash the value. We mod that, so we've got a number, and then we go to a lookup table, find that name, and we create collisions on that as well. So Gary can be masked to John, and Michael can be masked to John as well. It needs to be consistent. We need to do the same thing wherever it is, whether it's on a mainframe, or whether it's on SQL Server, or whether it's on Oracle, or whether it's on the CSV file, and it needs to be repeatable. So one of the things, when that first example I talked to you about, where they said it took 24 hours to mask data. What they actually meant was the service level was 24 hours. And that meant that you get the new database, we've refreshed the environment, it's a physical database, and now they have to run the masking job on it. So now you sit around waiting 24 hours, and then you can access the data. If you've got a virtual copy of the database that is on almost zero footprint, it means you can mask the data out of bounds because you've got enough storage to be able to do that. And because you can provision it almost instantly, you mask it in a different copy, and then you can bring the copy in when you need it. Saving 24 hours, let's say. One of the other things that, if you've got a virtualized infrastructure, one of the issues for moving into the cloud and doing testing in the cloud is the fact that you need to secure the data, so you need to mask the data, first of all. And then obviously, if you've got a 10 terabyte database, and you're going to push that across into the cloud, that's going to take a long time. Or you need to give Amazon a lot of money to get a direct link into your cloud. So with Delphix, if you've got a Delphix engine, what we do, that initial copy can be replicated across to another Delphix engine. And we do that on a throttled, intermittent basis. So actually, the first replication is going to take all of the. So if we had a 10 terabyte database, we've reduced it down to 3.5 terabytes. We've got to get 3.5 terabytes over here, which is going to take some time. But actually, once it's over there, we're only taking increments across every time after that. When we replicate, we're replicating an increment of the D source, an increment of the source data. And once we're in the engine, then we can spin up virtual copies almost instantly. So the real value of that, there's a couple of values around that. One is that we've got almost all the data over there. If you're migrating something from your on-premise environment to a cloud or another data center, we're getting all of the data over there, you're testing it, and at the point when you want to take the whole data across, then you've only got to put the increment across. And a capability that Delphix has is to be able to go from virtual to physical. So we can actually rehydrate the data. So we can say, here's a virtual database, put that onto a physical copy. And that's quite useful if you're running something like Exadata. So you have production Exadata, put it into Delphix, virtualize it, run all your tests, and then go put it back into Exadata. We're very near the end now. So the other capability, I told you about the API, we've got a REST API, and that allows us to plug into all of that integration architecture. So I had some people in my team create a thing called a Ruby gem, which meant they can use Puppet and Chef to actually run, because that's based on Ruby, so we could have create a recipe that actually fires up. So we can create virtual copies of data using these APIs. And the idea of having a virtual database is you can bring the data in, and once you've got it over here, then you can start to manipulate those virtual copies. And really, you can create this test data factory. So, you've got 5% subset, 10% subset, synthetic data, and you can start to deliver that out to your developers in a self-service kind of way. So there are a number of companies that use this. So FastWeb, what the idea was getting releases much more quickly. So they release their releases from weeks down to days. They would talk, I was talking to them a while back, and I think they've got about, I think it's about 60 applications. One set of data is 60 applications long. WebSphere, WebLogic, and they're virtualizing all of that to bring their provisioning time down to hours. City Index again, testing and release management. 75% faster development, and just getting that more IT output. If you can imagine, if you've got you own your own data and you go backwards and forwards in time, that's fantastic. Obviously, I mean, if you're a developer, you're just doing your unit tests, and you'll create some scripts in the database and you get your table back almost instantly. But this is about complex environments where you're resetting the whole thing and starting again, and you can do that very, very quickly. And Saab Miller, again, using SAP is another story entirely. Migrating SAP is a difficult subject, but again, having a virtual copy of the database really speeds up the testing cycle there. So not only can you test, so if you've got a virtualized infrastructure, you can accelerate releases. You can recover from outages as well. So Ingerstrike, actually, when what they were doing, they were keeping their backup copy, their data guard copy, two hours behind the production. So if there was a catastrophic failure in production, then that wouldn't replicate to their backup. Okay. With Delphix, they actually implement that, and they can now have data guard running directly in sync with their production, because all of the data is copied into the virtualized infrastructure. Talk about relocating data centers, we can comply because we've got the masking. We can offload production. So if you're doing BI, you have a virtual copy of the database, that's quite useful. And you can create a continuous delivery with the integration. So that's it really. And the final point is this: does anyone know who this guy is? Isaac Newton, yeah, that's right. So one of the things that he said was that if I've seen further, it's by standing on the shoulders of giants. And he was a very modest man, really, because he's a bit of a genius. Newton's laws of motion and gravity and that sort of thing. And I think if what you need to do in this test environment is to stand on the shoulders of giants. So the software that we create stands on some giant technology, and that is, we create our own version of ZFS, that copy on write storage technology, which is genius. I worked for Oracle for 10 years. I didn't understand the value of ZFS until I joined this company. We also use virtual hypervisors, so that's other technology that we leverage. And I think the value that we bring is because we're standing on top of that technology, and the value that you can get as testers is to stand on top of that virtualization capability to just do things that previously were impossible. So that's it from me. Like I said, I'm Gary Hallam. If you want to find out more about what we do, look at our websites. There's lots of other server virtualization technology, data virtualization technology out there. Take a look at it, see how you can bring it into your environment, because I guarantee it will speed up your delivery of applications. Thank you very much.